In this video, I want to look at a worked example of using integrals to find displacement and total distance solved. So I want you to, first of all, stop the video and read this example problem, maybe even try to do it for yourself before watching the rest of the video. So hopefully you stop the video, at least hopefully you've read the problem and written it down in your notes. This is how I go about solving this particular problem. First of all, there's some reading that's involved. We have to realize that the cosine of t is my velocity function. We are wanting to go between t is equal to 0 and t is equal to 5 pi over 4, and we are being asked to find both the displacement and the total distance traveled. And finally, we are also being asked to find whether or not the point is to the right or left of where it started. I am going to do the displacement part of this problem first because the displacement is actually the easier of the two questions. So for the displacement, let's see, I need to make that just a little bit more readable. So for displacement, all we need to do is find the definite integral from the starting value to the ending value, which were 0 and pi over 4, of our velocity function. And that will give us the displacement. Now, this is actually a very easy integral. I know the antiderivative of cosine of t is plus the sine of t. And I need to evaluate that between 0 and 5 pi over 4. So this is going to be the sine of 5 pi over 4 minus the sine of 0. Now, a lot of students have trouble getting these trig values of the principal angles that are not in the first quadrant, and I do want to introduce how I typically do a problem like sine of 5 pi over 4. I basically go back to the unit circle definitions for the trig functions, and 5 pi over 4 is going to be out here. This is 4 pi over 4, and I need one more pi over 4, so this is 5 pi over 4. And that means the sine of 5 pi over 4 is negative, and the pi over 4s are always plus or minus square root of 2 over 2's. So this particular value is going to be a minus square root of 2 over 2. And then the sine of 0 is simply 0. So our final answer on the displacement is minus the square root of 2 over 2. We still need to interpret this. Is the point to the right or left of where it started? Well, that's answered in the following way. Oops, gotta get a pen. Since the displacement is equal to minus the square root of 2 over 2, which is smaller than 0, the point is square root of 2 over 2 units to the left of where it was at t equals 0. And this is an indication of the kind of writing that you ought to be doing when you are answering a question like, is the point to the right or left of where it was? Well, now let's turn our attention to the second part of the problem. We were trying to find the total distance traveled, and I also wanted to make sure that I copied the velocity of the function. For this one, I need to understand that the total distance is equal to the integral between 0 and 5 pi over 4 of the absolute value of the velocity function. Now, to figure out what I'm actually integrating, I need to graph y equals cosine of x. Or technically, I'm graphing y is equal to cosine of t, So let me put a t in there just for consistency. So I'm going to draw a sine wave, and then I'm going to put the axes on it. All sine and cosine graphs look something like this. And it's just a matter of getting the axes in the right place. And the independent variable axis is always going to cut the humps right smack in half. Now, since I have a cosine curve, the cosine of 0 is 1, and so the y-axis cuts one of the humps at its highest point. So this is my t-axis, and this is my y-axis. This point here is 2 pi, and this point is pi. And I want to put in a different color that 5 pi over 4 is just a little bit bigger than pi. So we are actually integrating the stuff for cosine of x that is over this interval. And what I notice is that we have a sign change, as in a plus or minus sign change. Cosine of t is equal to 0 at pi over 2. So we have to split this integral up at pi over 2 so that we're getting this area is positive, and I want to flip this area over the x-axis and graph y is equal to the absolute value of cosine of t, which on that interval will just be minus the cosine of t. In other words, at this point, I want to say that the total distance is going to be the integral between 0 and pi over 2 of cosine of t dt, and I'm going to add to that the integral between pi over 2 and 5 pi over 2 of minus the cosine of t dt, because on this interval minus the cosine will be positive. So let's see, how am I going to do this? Well, I know how to do both of these integrals. This integral is going to be the sine of t, and I'm going to need to integrate between 0 and pi over 2. And this one is going to be minus the sine of t, and I need to evaluate that between pi over 2 and 5 pi over 4. And I just noticed I have a copying error. That should be a 4, because my original thing is going up to 5 pi over 4. Now it's a matter of just plugging the numbers in, but I have to be super careful of the minus signs. So in this one, I'm going to simply have sine of pi over 2 minus the sine of 0. Now I'm going to get, because of this minus sign, I'm going to have minus the sine of 5 pi over 4 minus a minus sine of pi over 2 inside this set of brackets. And now it's just a matter of figuring out what these numbers are. And we've already seen that the sine of 5 pi over 4 was minus the square root of 2. That was from before. So now what we're going to do is just plug the numbers in. Sine of pi over 2 is a 1. Sine of 0 is a 0. And now we're going to have minus a minus square root of 2 over 2, minus a minus because that was already a plus, the sine of pi over 2, which is a 1. And what I've got now is 1 plus square root of 2 over 2 plus 1, which is 2 plus the square root of 2 over 2. And I want to say what this answer means in the context of the problem. The total distance traveled is equal to 2 plus square root of 2 over 2 units.